All right, everybody. So today, this will be for Thursday and Monday. Okay, and this will also be our last section before the test. So, just so you know where we are in the grand scheme of things. All right, so today we'll look at just-in-time 3.1 through 3.3. So we're talking about solving different kinds of equations. Okay. So the first type of equation we'll talk about solving is just linear equations or equations of degree 1. And the paragraph here is just kind of standards. And most of this is stuff that we've already used in the class. This is kind of just us formally introducing it, but just so that we're all. So we've got the expression of ax plus b, where a is not 0, is a polynomial of degree 1. So that our equation ax plus b equal to 0 is called an equation of degree 1. And we know that the graph of that is a straight line. Okay. So we can solve for different variables. So in this case, if we're solving for x, we want our final answer to be x equals to something. Okay. It may be a number, it may be an equation. Either way, it's done the same. All right, so if we're solving for x, we want to collect all of our x terms on one side and all of our other terms on the other side. Okay, so we can add, if we subtract this y, and we pull it over here, and we also can subtract the 1 from both sides, so we get 2x, 5y minus 1y is plus 4y minus 1, because 0 minus 1 is just negative 1, and that's equal to 3x. So then I can subtract my 2x over here. Okay, and we're left with 4y minus 1 is equal to x, which is what we were looking for. Okay, you could have started by moving the 5y over this way. It would have gotten the same way. All right, I'm going to do another example. So in this case, we want to solve for y. So we can subtract this 3/4 y over. Okay, we can also add the 1 over. And subtract the 2x. Okay, and so what we end up being left with is 2/3 minus 3/4 y is equal to negative x, because x minus 2x, it's just negative x, and then we've got negative a half plus 1, so plus a half. Okay, and then 2/3 minus 3/4 is just going to give us negative 1/12. So it'd be negative 1/12 y is equal to negative x plus 1/6. Sorry, 1/2. And then to finally get y by itself, we'll multiply both sides by the reciprocal of that fraction. So be negative 12 is what we're going to multiply both sides by. Okay, because then that clears this fraction, and we're left with y equals 12x minus 6. Okay, anytime you've got a fraction like this that you want to clear, you can just multiply by the, you can just invert it and multiply. Okay, so that's linear equations. Our other kind of equations we've got is quadratic equations. So quadratic equations are polynomials of degree 2. We know that they're the U shape. And we can find the roots of a quadratic equation using the quadratic formula or one of our factoring methods that we've been talking about. Okay, So if we want to use the quadratic formula to solve for s, we can say, okay, well, s is equal to -4 plus or minus the square root of 4 squared minus 4, 1, 4 all over 2, because we've got our a is 1, our b is 4, and our c is 4. So we just plug those into the formula. And we're left with -1 plus or minus the square root of 16 minus 16 over 2. So -4 over 2, which implies that s is equal to -2. Okay. We only have one solution to this one because this is 0. If that wasn't 0, then we would have 2 solutions. All right. We'll do one more example. So in the quadratic formula, this piece under the root, then b squared minus 4ac, that should have a squared on it. Okay, b squared minus 4c, that's called our discriminant. And so if that is negative or less than 0, then our equation has no real roots. They're complex numbers. And so we can write them, if we define I to be the square root of -1, which is an imaginary number, then we can just rewrite it in terms of I, and we get our complex number. Okay, so we'll do an example like that. If I've got this equation and I want to solve for y, our a is 1, b is 2, c is 2. So y is going to be equal to -2 plus or minus the square root of 2 squared minus 4 times 1 times 2 over 2. So I simplify it and I get -2 plus or minus the square root of 4 minus 8 over 2. So -2 plus or minus the square root of -4 over 2. So -4, so I can take my root and I can break it up and write it as square root of 4 times the square root of -1. And then rewrite that so we know that'll be -2 plus or minus square root of 4 is just 2. Square root of -1 is I over 2. And we can factor out a 2 and cancel it. So we get that y is equal to -1 plus or minus I. Okay. If you were to do something, or if you were to be asked a question and it asked for what were the real roots, then in this case you would say there were none. But if they just ask you for all solutions, then you'd put the complex ones in as well. Okay, and our last type of equation we'll look at, or it's just other equations in general. We'll look at these two. This one and one other example. Sorry, 2 other examples. So in this case, what we want to do is we want to try to clear the fraction. So we'll multiply by the common denominator. And our common denominator in this case is going to be x minus 5 times x plus 5, because that's what x squared minus 25 factors into. So if we multiply, so if we've got 1 over x minus 5 plus 1 over x plus 5 is equal to 10 over x minus 5, x plus 5. Then we multiply by the whole thing by our common denominator. So every term gets multiplied by it. Okay, so then we've got 1 over x minus 5 times x minus 5 times x plus 5 plus 1 over x plus 5 times x minus 5 times x plus 5 is equal to 10 over x minus 5 times x plus 5 multiplied by x minus 5, x plus 5. Okay, and so then we can cancel. So that whole thing will cancel. That whole denominator will cancel. For 1 over x plus 5, we can cancel the x plus 5. For x minus 5, we can cancel those. And so we're left with x plus 5 plus x minus 5 is equal to 10. Okay, because I took whatever was left from canceling. All right, that cleared our fractions away, and we can just solve this like we would if we were solving for x. Okay, so we'll take, and we can combine our terms. So this is just x plus 5 plus x minus 5 is equal to 10. 5's cancel. So we're left with 2x is equal to 10. So x is equal to 5. Now, we have to ask ourselves, because of the type of equation we're looking at, rationals, we have to ask ourselves, does this make sense? Okay, and it doesn't, because if I were to plug this back into my equation, I would end up with a 0 in a denominator. Okay, so no, it doesn't make sense, because you can't have x equal to 5, because that would give you a denominator of 0. Okay, so with these, you have to check and make sure that your answer is in the domain, is another way to think about this. So our domain for this function would be anything except for what would make the denominator 0, which for this would be, so everything except for -5 and 5. Okay, thinking back to when we talked about domains. And because 5 is not in the denominator, or 5 is not in the domain, then our answer is just that there are no solutions. Okay. All right. All right, a couple more examples. So we've got another example that's like this one, like the one we did before. So again, we're looking for the least common denominator. So that's really x plus 6 times x minus 6. So that's our common denominator. Okay, so we'll multiply everything by that. So x over x minus 6 times x plus 6, x minus 6, minus 24 x squared minus 36 times x plus 6, x minus 6, equal to 2 over x plus 6 times x plus 6 times x minus 6. Okay, and then we can cancel. We know that whole thing will cancel. X minus 6 will cancel from here, and our x plus 6 will cancel from here. So we're left with x times x plus 6 minus 24 is equal to 2 times x minus 6. And so we can then start trying to simplify. So we've got x squared plus 6x minus 24 is equal to 2x minus 12. Because I see I've got an x squared, I can say, okay, well, this is a quadratic. So I can move all of my terms onto one side and set it equal to 0. And so we get x squared plus 4x minus 12 is equal to 0, which we can then factor. So x plus 6, x minus 2 is what that factors to be. We set each is equal to 0. And we get that x is equal to -6 and x is equal to 2. But do both of these make sense? So what's our domain? Our domain for this one is going to be everything except for -6 and 6. Okay, so -6 does not work because it's not in our domain, but x minus 2 is an acceptable answer. Okay, so that's a solution. So sometimes you'll get to where you might have one solution that works and one solution that doesn't. And when that's the case, you just need to somehow identify that you know which one is the actual solution. So by boxing it in or crossing the other off. Okay, we need to see that you know that step in there. Okay. All right, so 2 more examples. So I've tried to cover every case you might see. So one other type of equation you might see when trying to solve is quadratics of higher orders than 2. So you can't just factor it. Well, you might be able to do some, but some of them you can't just factor. So what we do then is say, okay, well, can I write this in terms of something squared? So we know that, so if we let y equal x squared, okay, then we know we've got x to the 4th minus 5x squared minus 36 is equal to 0. That's the same as x squared squared minus 5x squared minus 36 is equal to 0. So I can take and plug this y in for my x squareds. And that's going to give me a y squared minus 5y minus 36 is equal to 0, which we can then factor. And in this case, we're going to want to do factor by grouping. So we're going to look for factors of 36. That can be, we know we'll have negative will be the sign of the larger number. Okay, we want a difference of 5, so that'll be 4 or 9 minus 4. Okay, so we can rewrite this and it'll be y squared minus 9y plus 4y minus 36 is equal to 0. So then we've got our 2 pairs. So we'll factor out a y from up here, and we get y times y minus 9. Factor out a 4, so we get 4 times y minus 9. So then we can factor once more, and we get y plus 4 times y minus 9 is equal to 0. So set both of those equal to 0. Y plus 4 is equal to 0, so y is equal to negative 4. Y minus 9 is equal to 0, so y is equal to 9. Now, up until this point, everything has stayed the same for normal factoring once we wrote that in terms of y. Here's where you have to make sure you do this last step. So what did say y was equal to? Well, y is equal to x squared. So we have to remember to replug that back in because we're looking for x. So we have to replug that back in and actually solve for x, not just y. Okay, so we know that x squared is now going to be equal to negative 4, and x squared is going to be equal to 9. So we solve for x, we get x is equal to square root positive or negative square root of negative 4, and x is equal to the positive or negative square root of 9. You've got to make sure when you're solving equations like this, you have that positive or negative, because those are both solutions. Okay, so we simplify and we get x is equal to positive or negative 2i, and x is equal to positive or negative 3. So we've got 2 complex roots. We've got 2 real roots or solutions. So what answer you give in this case depends on what their question is asking you. So if it's asking you for all real solutions, okay, then in that case, your answer would just be plus or minus 3. If it's asking you for all solutions, okay, then you would list all of them, whether they were complex or real. Okay. So, all right, we'll do one more example of this higher order polynomial with the substitution. So if we've got something like x to the 6th plus 6x cubed minus 16 is equal to 0, and we want to solve for x, we can say, okay, well, we can rewrite this as x cubed squared plus 6x cubed minus 16 is equal to 0. So we let y equal x cubed. When we try to figure out what we want to let y be, you want to let it be something that when you plug it in, you're going to get a regular quadratic. Okay, that's your goal with doing that. So we plug it in and we get y squared plus 6y minus 16. And after you plug it in, you should not have any x's left. If you do, you've done something wrong. All right. So now we can, once again, we'll do by grouping. 2 and 8 should give us a difference of 6. So we'll have y squared plus 8y minus 2y minus 16 is equal to 0. Okay. Factor both of those, we get y times y plus 8 minus 2 times y plus 8. Okay, so when I factored that, I didn't just factor the 2 out, I factored the negative 2 out. So that's why I get a negative 2 and I have that sign being different in there. All right, so I factor once more, I get y minus 2 times y plus 8 equal to 0. Set both of these equal to 0. Y minus 2 is equal to 0, gives us y equals 2. Y plus 8 equal to 0 gives us y is equal to minus 8. Okay, and then remembering to resubstitute from up here. So we said that y was equal to x cubed, so we substitute that back down. So we get x cubed is equal to 2, x cubed is equal to negative 8. And so we take the cube root of both sides, so cube root of 2, and x is equal to the cube root of negative 8. Now remember, odd orders, we can have negatives on the inside and we don't have the plus or minus. Okay, so we can do this and this is just equal to negative 2. Okay, so both are valid because of the odd root. Okay. All right. If you've got questions, you can ask me, you can either email me or ask me in class.